Hello everybody. Welcome back. So now we are finished. We are finished with writing our block, the second block, so to speak. So now we want to go to the boundary. This is just entry, we can just ignore. We want to go to the boundary. All right. Now we want to also rename our boundaries. Okay, so moving wall, that was actually from the cavity form. That was the top boundary, because this is the y and this is the x direction. Okay, and inside is the z direction. So that's how how the cavity file was supposedly conceived. Okay, so it's slightly mixed up. It's not like this anymore, where you have the z on top, the y this way, and then the x this way. That's not the way. Alright, so I'm gonna cut that out. Okay, and we want to, okay, I'll leave it there. Okay, we'll just have two new squares again. Okay, two identical squares. Alright, so we'll have the top plane we want to define. This was the old part where it was previously in the cavity case in OpenFoam. It was moving at 1 meter per second this way, approximately, if I'm not wrong. We have that. Now we want to replaced by, let's call this the top plane then. Okay, maybe we can call it the top y plane. So let's call it the top y plane. Then of course we'll need to change lots of things after that. Top y plane. Let's use some underscore. Okay, so this is what I'll call it, top y plane. Now the type is of course the wall, and of course we have the faces. Okay, 3, 7, 6, 2. Where is 3, 7, 6, and 2? Let's go back to our Excel file. I'm gonna unhighlight everything. So use the format painter to unhighlight it. That basically just copies and pastes the format from, let's say, this cell into this cell. Okay. If I want to copy the format from here, I'll do this, and then you'll just copy and paste the format. Okay, so that aside, let's look at 3, 7, 6, and 2. 3, 7, 6, and 2. Okay, so 3, 2, 6, and 7. Now what do they all have in common? The y coordinate equals to 1. Now we want to have all the y coordinates equals to 1 highlighted, so that we can define the other face. Okay, not just for this part, but for this part. Okay, so 3, 7, 6, and 2 is for this part. X equals 0, this one's x equals to 1, and we got an x equals to 2. So if you notice the 0.376 and 2, all of them have x equals 1 or 0 on here. So if you want to define this plane, you need to have x equals 1 or 2. Okay, so we will need x equals to 1 or 2. So that is 2, 6, 9, and 11. So we have 0.2, 6, 9, and 11. Okay, so I'm just going to erase this. Okay, 0.3 and 0.7. So you see all the x equals 1 or 2 when it's highlighted. And where is this? Is this the top or bottom y plane? Well, since y is this direction, this is the top y plane, this is the bottom y plane. Alright, so this is the large y plane. We have to use these sets of instructions. Firstly, we look for the least x and z. Okay, so that will be 0.2. We add the z, so z goes from 0 to 0.1. We'll have 0.6. Well, then we'll add x from 0.6. That's 0.11. So you see, and the thought process is as so. You have 0.2, which is the least x and z. We're going to add the z coordinate. So it's 1, 1, and 0.1. So this is the only coordinate that's added. Next step is to add x will be here. And then this will naturally be the last point. Okay. And so we can do something similar to what our writing blocks are doing. No? Okay, I'm going to insert. We're going to have our output. All right. And so we'll just do the same formula again. Okay, I'm going to do it this way. Okay, I'm gonna copy these formulas down. 1, 2, 3, 4. And all these I'm going to just erase them away. Let's see. Okay. This one goes first. Then you'll have this, then a space, and this, and a space, this, a space, this, and then you have this. Well, I think there's something wrong. There's a problem. X3. Let's see. I think I typed something wrong there. This comma, this. Ah, there's a comma. There you go. That's the output. Copy, paste, and you just use the values. 2, 6, 11, 9. That's the second one. Okay. 2, 6, 11, 9. And then we will put it here. This is x equals 1 and x equals 2. And x equals to 0. Okay. 0 and x equals 1. Write it in. That is it. Top y plane is done. Okay, this is done. Toop. There you go. Now we will want to move on to the next one. Let's see what this is. This is the bottom wall. Okay, bottom wall is 1540. What's 154 and 0? Let's take a look. 1. Okay, we just unhighlight everything first. 1. 1, 4, 5, and 0. What is common among all of these? All of these have y coordinate equals to 0. And so these are, this plane is talking about this one over here. And we don't want a non-moving wall. We want to call this, okay, So the top, we call it the top y plane with underscores and capital letter. This one, we just want to call, well, it shouldn't be here. This one we want to call zero gradients. Zero gradients. These are zero gradients planes. That's the boundary conditions we want. So it's here and here. Okay, so let's just call these the, yeah, okay, we'll just call these the zero gradient planes. All right, we'll call it the zero gradient planes because they're not characterized by the position, but we'll just call them zero gradient planes because they are the same boundary condition. So I believe we can call this a patch. The type is patch. Alright, the type is patch, not wall. And we have 1540 on one side. Okay, that is this part, 1540. So we can call this this is the bottom left. All right, this is the bottom left side. X equals to 0 and x equals to 1. X equals to 0 and 1 and y equals to 0. Okay, that's what characterizes this plane. The next thing we want is, let's say, this side. This is the outlet side. So how do we write this side? Now this side, all these are characterized by x equals to 2. Okay, and they're part of this block. Okay, so what kind of a plane is this? This is a small x, this is the large x. So this is a large x plane from this block's point of view. So we look for x equals to 2. So I'm going to unhighlight all this and look for x equals to 2, 8, 9, 10, and 11, very conveniently. We call that it's a large x kind of a plane. So we look for the least y and z, 8, we add the y, then we add the z, and we subtract the y, 8, 9, 11, 10. Okay. So you can see, right, that it's very easy to write with this kind of it's much easier to write instead of you having to figure out what it is. All right, this is left side outlet, so that's equal to x equals to 2 plane. Okay, and then one more we want to get is this one, this top plane here. This top right hand side plane, what is it characterized by? It's characterized by y equals to 1. So it's a large y plane. It's part of this box. It's the large y plane of this box. I call it a large y plane. Okay, so it's characterized by y equals 1 and x equals to 1 to 2. So let's look for the y equals to 1 planes. Okay, before anything, we save. Okay, we're gonna unhighlight it. So we are looking for y equals to 1, x equals 1 to 2. This is this point, yeah. Okay, and y equals to 1 plane, x equals 1 and 2, so 1, 1, x equals 1, y equals to 1. 2, 6, 9, and 11 will be our planes. So what kind of a plane is this? This is a large Y kind of a plane. Did I type it wrong? I think I typed something wrong there. No, not wrong. Okay. So this is a large Y plane. Okay. Oh, we already have the top Y planes here. We don't need to rewrite them again. Okay. So, yeah. We don't need to double write. I think I made a mistake. We don't need to double write this again because this was already defined. So this and this will be the zero gradient planes. You know, conveniently, if you want to group all the zero gradient planes together, we can just copy and paste these two things over. Okay, so this will make it more consistent, much easier because we want to define it by the same kind of boundary conditions. Top Y plane equals to 1. Top Y plane Y equals to 1. Okay. So that's how we get it done. I'm just gonna delete all of this. Okay. So that should do it. Type is patch. All of these are zero gradient plane. So now we want the left side. The left side is x equals to 0. Alright. So that's, I'll use a green color. This is the plane we're talking about. Alright, 0, 4, 7, 3. Nothing too different. Okay. And yeah, nothing too different for this plane. We'll just leave it as it is. Type is a patch. Now there's no more right side anymore. There's no more right side anymore. Because we already defined that as by the zero gradient. So I just change the left side to, I'll just call it an inlet. Okay, because we'll have the free streams coming in from here, from this inlet. Okay, free stream coming in from this inlet. It looks like I'm disconnected, but anyway, whatever. Well, it's a free stream coming in from this inlet, so we just name that inlet. So this is a zero gradient. This is zero gradient. This is zero gradient. Okay. So it's called zero gradient planes. The right side. Okay. This 2651, it was originally here, but we don't need that anymore. In fact, we don't even need this side because we don't need to define that side because it's already defined in our zero gradient planes. So the right side, we can just use it to define this part, which is the no slip condition. We can just call it the plate because that's where our plate will be. Plate, the type we can call it a wall, and the faces will not be 2651 anymore. The faces, this, oopsie. Okay. All right, fine. Okay, in case you notice, there must be this curly bracket and it's open and close if you delete the wrong code. Okay, but as long as you have a curly bracket here and here, and a normal bracket here and here with this semicolon, you should be fine. Okay, so this is the wall where y equals to 0, x equals 1, and x equals to 2. Okay. How are we going to write this part? Okay, let's identify what kind of plane this is. This is a low y plane because it's part of this box. This is the high y, this is the low y. Alright. Then next we will need to get this small y plane. So again, we'll do the same thing. We identify the points. We have y equals 0 points and x equals to 1 and 2. So that will be this. And this. These are y equals to 0 because it's at the bottom. So we can see which points already light up. 1, 5, 8, and 10. So we just cancel this out to avoid confusion. This as well. I'm going to copy and paste this concatenate. 1, 2, 3, 4, 5. It's very useful. 1, 5, 8, and 10. This is a small y plane. So we are asked to look for the least x and z. That is point 1. We want to add x. Adding x will result in 0.8. We want to then add z. Okay, we add z, that's 0.10. Then we want to subtract x, that's the last one, 0.5. 1, 8, 10, 5. Alright, so we're just going to copy and paste them here. And that will be our wall face. Now I'm going to stop here before it goes too long. Yeah, I'll probably take a break. In the next video, we will continue with this front and back faces, and then we'll try and initialize our changes into the OpenFoam and run our simulation and see what happens, what's going on. Alright, so thanks for watching. I'll see you guys in the next video. Bye bye.